Then we just plug whatever we think here back into our equation. So we would get the first term, we don't need to do anything, you just copy it there. The second term, we got to replace n with n minus 1. So we get n minus 1 square a n minus 1 t to the power n minus 2. And the third term, we replace n with n minus 2. So we get n minus 2 equal to 0 till infinity. And then n minus 2 square plus n minus 2 minus 12 a n minus 2 t to the power n minus 2 equal to 0. Now we have the whole term with the same power. But the thing is that n is not started with the same point. Just rewrite it again. And then 2 summation n minus 1 equal to 0, so n is equal to 1. N equal to 2 to infinity. Again, because n is not started with the same point, so the thing that we are going to do is that we plug each term in order to make n start with 2. So the first term, if we replace n equal to 0, what do we get? 0. If we put n equal to 1, still 0. So then we plus the rest. This one plug n equal to 1 there, what would you get? 0 again. Doing that, we would get the whole term starting with the same point that n is equal to 2 until infinity. So that means we all set. And then we combine each term together. Now we can combine all three terms together, right? Because first we have the same power of t, and the second is that we have the starting point at n equal to 2, which is the same. We write down in such a way that we combine all three terms together. So we do the comparing the coefficients. As you can see that if you want to make this equation equal to 0, there is two ways. The first way is t to the power n minus 2 is equal to 0, which is trivial one. So the other way that we can make this equation equal to 0 is just that having the term in the parentheses equal to 0. And from doing that we would get the recurrence relation. this one right when n is equal to 2 or greater than 2. We rearrange it again and then we would get this is called the recurrence relation. So we just put again, like after we got recurrence relation, we plug n into this relationship in order to get the relation of A2, A1, and A0. We got to have this relationship first before we plug into our solution. Okay, so we put n equal to 2 there. We got A2 equal to what? Oops. Did I do wrong, right? This one is minus 1. And then this one got to be minus 1. Where is it now? That one? And then this one, right? And then this one. Okay. Anywhere else? Too many numbers. That's what I said. This one is not hard, but it's just long. And then so confused with the signs. I mean, the negative and positive signs got to be right. I mean, like whenever you write it down, just very careful about it. You can do mistake all the time. They have a place that you can put the mistake there, just like I did, right? Okay, when we plug n equal to 2 there, what would we get? 2a1, right? 2a1, n equal to 2, so we got minus 12a0 divided by 3 times 2 times 1. Put 6 there first. I mean, if we can't arrange into any relation, just try to put like the whole number first. Unless we can. But if we can't, just leave it like there. N equal to 3, A3 equal to 8, right? Just plug the number in there, then we'll figure it out. 3 minus 1 equal to 2, 2 square, 8. 3 minus 1 equal to 2. 3 minus 2, 1 square plus 1 minus 12, A 3, A1. 3 times n is equal to 3, n minus 1 equal to 2, which is what? 8, A2. 1 plus 1 equal to 2, 2 minus 12 is equal to minus 10, A1. 18, right? But we know that our A2 is just in the term of A1 and A0. You just plug A1 and A, you just plug the value of A2 into this equation. So you would get 8 times or 80. So from this, what do we get? This term and this term, you can combine them together, right? Why is this negative, right? Because this one is bigger than that one. So negative minus 30 plus 8 is minus 22, right? This one we get what? 48 divided by time, and so on. Now our solution is that y is equal to summation n equal to 0 to infinity an x minus 1 to the power n, right? Now we don't need to put into the term of t because we already got the recurrence relation. So we know that our a related to each other into what form, okay? Okay. Like that. What is the equation of this? They're asking us to find the solution, right? And then if y is equal to 1, if x equal to 1, y equal to minus 7, and x equal to 1, the first derivative of y equal to 3, then we have to find y at x equal to 0. Okay, in that case, okay, because we know the relationship there, so the answer would be this form, and then you just plug. So you know that the rest of the term, it would be in the form of A1 and A0. So you know why already. Now we are going to plug the boundary condition in there. They're saying that now we are going to find y where x equal to 0. At x equal to 1, y equal to minus 7. So if we plug this value into our solution. So we would get 7 is equal to A0. Right? Because the rest is x equal to 1, the rest are 0. So we know that our A0 is equal to minus 7. And our boundary, this second boundary is saying that at x equal to 1, the first derivative of y is equal to 3. So we've got to do the first derivative of our answer. We would get the first derivative is equal to, the first term equal to 0, the second term is equal to a1, the third term is equal to 2a2 times x minus 1, and so on. So the rest, you would have the term of x minus 1, right? Then we plus boundary in there, so we would get a1 is equal to 3. So in that case, we have y is equal to, oh, we know the value of a1 and a0 now. We have the value of a1 and a0. The thing is that the problem statement asking us that what would be the value of y where x equal to 0. So we got to plug the value of a1 and a0 into our recurrence relation. Okay. Now we know that our a2 is equal to 2a1 minus 12a0 divided by 6. a1 is equal to 3. Put 3 in there. a0 is equal to minus 7, which is what? Minus 7 times minus 12 plus what? 84 divided by 6, which is equal to 90 divided by 6, which is equal to 15, right? Our a3 is equal to, because we know the number already, we are going to use our recurrence relations again in order to get the exact number of a3 and a4 and a5, right? So a3 equal to 2 times n is equal to 3 is 2 square times an minus 1, which is a2. Let's just make a copy of this. That we did it before, but now we know the value of a2, right? a2 is equal to 15. You've got 15 times 8. We got 50, 8 times 15 minus 10 times a1 is equal to 3 divided by 18, which is equal to 120 minus 30 divided by 18, which is equal to 90 divided by 18, equal to 5, right? Now a4 is equal to, we just plug into this relation. N equal to 4, you got 2 times 4 minus 1 equal to 3 square, an minus 1 a3 plus n equal to 4, 4 minus 2 equal to 2 square, 4 minus 2 is 2 minus 12, a what? 2 divided by 3 times 4 times 3. Now our a3 is equal to 5 and our a2 is equal to 15, right? Which is 18 a3 minus 4 plus 2 equal to 6. 6 minus 12 is equal to minus 6a2 divided by 3 times 4 times 3. a3 is equal to 5. 18 times 5 minus 6 times a2, which is 15, equal to what? 18 times 5 equal to 90. 16 times 15 equal to 90, equal to 0. Now a4 0. Divide a5. a5 is equal to what? 2 times 5 minus 1 is 4 square. Times 4 square, a what? a4, right? Which is 0. Plus 3 square plus 3 minus 12, a what? 3 divided by 3 times 5 times 4. This term is equal to 0 because a4 is equal to 0. 9 plus 3, 12 minus 12, 0. So a5 is equal to 0. If you find a6 is going to be the term of a5 and a4, right? So a6 equal to 0 and a7, 8, 9, 10 going to be a6, a7, and so on equal to 0, right? Because it becomes 0 since a4. a6 is in the term of a5 and a4. a7 is going to be in the term of a6 and a5. a8 going to be in the term of a7 and a6. So they are 0 already. Now the rest of the term would be 0. So now you have y is equal to plus a3x minus 1 to the power 3. That's it, right? Because a4, a5, a6, they're all 0. Now you have only 1, 2, 3, 4 terms left. And you know that a0 is equal to minus 7, and a1 is equal to 3, and a2 is equal to 15, and a3 is equal to 5. Now they're asking you what would be the value of y at x equal to 0. So y is equal to minus 7 minus 3, right? 0 plus 15, right? 0 minus 5. What is it? 10, 15, 0. So the value of y at x equals to 0 is equal to 0.